Before we get started with implementing the grabbing, we're going to do something about how our game looks. Right now, the colors are quite bland and a little bit boring, and they don't fit with the character's cartoonish look. So if we have a look at our player here, let's just move him so we get him in the center of the screen roughly. We can see that he looks quite grayish and nothing really sticks out color-wise. And a big part of it is because of our post-processing filter that we have enabled. So on our global volume, we can see which post-processing effects we are running, and they are coming from this sample scene profile, which you get with Unity when you create a new project. If you don't have a profile, you can go and create it, right click, create, and then you have volume profile here, and just call it anything, and you can add overrides and the filters you want. But now we're going to change our sample scene profile here. And a big part of getting a cartoonish look here is to enhance the colors. So we are going to add an override, and it's going to be a post-processing color adjustment. And we want to bring up our contrast so that the colors become more exaggerated. So if we increase this, we can see that okay, the colors are coming out stronger, but if we overdo it, then it's going to be way too bright. So let's go with something 27-ish. And another part is the saturation. So if we decrease saturation, it's going to be this gray scale, almost boring. And if we increase our saturation, we are going to get more strong colors from this. And if we overdo it once again, it's going to be, well, too much. So let's bring it down to 30 something. There. So this is a better view for our game, and if we disable the color adjustments, we can see that yeah, it makes a big difference. Some colors may not match what you expect because you have changed the contrast and saturation, but this is something that you can tweak and also change the colors in your world to make sure that it matches your, well, concept. So yeah, that's a good adjustment. And once again, if you don't have a global volume, make sure that you create a volume and then you attach the sample scene profile or whatever profile you're running. And also make sure that your camera has post-processing enabled. So rendering, post-processing checked. Now we can get started with implementing the grabbing feature. Some of you, however, have reported that your night animated does not have an avatar. And for what we have been doing so far with the animations, it doesn't really matter. You don't need an avatar. But for the grabbing part, we are going to need an avatar. So here's how you fix the missing avatar. So I click the avatar, and on the night you should have an avatar. And if there is no night avatar, then you need to create one. So I can show you how you do it on the mage. So the mage doesn't have an avatar. There is no mage avatar here. And what you do is select the FBX file. Then you go into rig here, and you can see that there is no avatar selected here. And select create from this model. And the root, you can leave it as none, and then hit apply. So that will create a generic avatar for us. And under our mage here, we will have an avatar appear. There we go, mage avatar. So now there is an avatar. So that's how you create an avatar if there is, if you don't have an avatar already. Now, why is this important for a grabbing mechanism? Well, it is because we want to make it easier for us to animate our character. So we have our knight animated here, which is going to walk, so it's walking, but at the same time we want to be able to grab things with our arms. So the arm should move into a forward position, and we don't want to create animations just for walking and carrying and then walking and throwing, etc. We want the arms to be separated from the rest of the animations, and for that we can use an animation mask or an avatar mask. And if we look at our animator here, and if we have a look at our different animations, we can see that we have a base layer and we have the ability to create a new layer that we can call, for instance, carry. And in our layer here, we can select override, how much weight it should override with a mask here, avatar mask. And we want this part to override 100% when we are trying to carrying things, and then it could be reduced when we're not carrying anything. So the character would then go back into the base layer and get the information from there. But we need an avatar mask in order to do this. So let's go into our FBX folder here. Either we can place it in animations or just keep it in FBX. Right click and create, and then find avatar mask, and then we can call it night hands avatar arms, maybe it's arms avatar mask. Okay, and then let's expand this one, and we can see, okay, which IKs are going to be used for this knight arms. So let's click on the ones we don't want, and so in this case we're just going to keep the arms and the hands. And then we need to expand our transforms here. So the transforms are going to be exactly which transforms are going to be changed, because we're not deriving this from IK only. So in this case we need to feed it with an avatar. So let's find our knight avatar here, put it in there, and then hit import skeleton, and that imports all the different parts. And we can say that, okay, we're gonna remove everything, and then expand our rig and our root, and just let's uncheck everything and expand all. If we expand all, then we can see everything, but we still need to uncheck everything. There is probably a way to uncheck everything, but well, I'll do it this way. Maybe there's someone in the top. No. So anyway, uncheck everything. So nothing is influenced by our by this mask right now. And then we need to find, okay, our upper arm. That's what we want to be able to animate, and our upper arm right. So those two parts is going to be driven by this mask, and that will cause it to just change these parts. Then we need to create an animation, and that forces the character to sort of extend its arms so it's easier to grab something, and maybe another animation when it's actually carrying something. So let's take our running custom here, duplicate it, and then let's just rename it to arms forward. And if we look at our knight animated and go to scenes, we can then select our running a custom. It's not here, the new animation. And why is it not here, carry arms forward? Well, it's because we need to assign it to our animator here. So let's take our running, arms forward. And because we have a nice animations here, let's just move it into our animations folder, so we keep it nice and tidy. So now we have arms forward in our animator, and then if we select arm knight animated animations, we can now select the arms forward. And let's take all of our keyframes and delete them. So if we have a look at our character, what do we want? Well, we want the character to extend its arms forward, right? And to make our animations a little bit easier to work with, let's disable our knight here, And in our model, animated knight is the one that we want to be able to view at the moment. So let's enable everything. And now if we are playing it, we can see that, okay, we are getting movement and we can see what's going on in our scene. So this is how the running a custom looks like. So then let's select our arms forward, and then it resets into this T-pose. So if we now hit our record here, and let's go to scrub to 10 and hit record, then we want the arms to become, well, the final position of whatever we want. So make sure that we have knight animated selected here, and upper arm is what we are going to use for this rotation. So not in the X minus 90. We needed to rotate forward, right? So that's backwards, and then down. No, there we go. So when we wanted to carry something, I think this sort of pose could work, and maybe that we bring it down a little bit more and wider. So that makes it easier to pick things up. So something that is close to his hand here is going to be attached to our object. Then let's right click and select copy Euler angles. Go to right arm and paste. And then fix so it becomes a little bit wider. So I think something like this would work if we would pick up a box in front of him. What you can do as well is you can sort of tilt the hips or the body over the box that you're trying to pick up. But for now I think this will be fine. Then hit stop recording. So that's that would work, I would say. And then in our projects we need something when we are carrying as well. So let's take our arms forward, duplicate it, and let's call it arms carry. And make sure that it's used. So let's just bring it in here. And then go back into our knight animated. And then let's hit animation and arms carry. So arms carry, let's copy the last frames here and remove this so it doesn't start from a T-pose, it starts from this. And then we want the arms to be more raised, so let's record this. And let's just bring it up. Something like this. So minus 48. Let's see if it, no. Oh. Something like that, I think. So it's going to bring up whatever we're trying to carry a little bit higher so it doesn't hit the ground. Maybe we can make it even. Let's keep it as that. So let's stop recording. So now we have our animations that we need, and we'll see, maybe we need to tweak this later, but it's a good start at least. So now let's go into our animator and rename carry, we can call it instead arms. So this will override our arms. And mask here, make sure that we have our knight mask and set to override, and then wait 1. And we wanted to start not in the arms forward, but instead we wanted to have an idle, so let's grab an idle animation. Idle. And right click, make set default layer state. Okay, so now we want to be able to control whenever this changes from idle into arms forward and arms carry. So we need some parameters for that. So let's hit parameters and then plus, and we will do a bool. And let's add an is grabbing. and another bool is carrying. And then let's have a look at our animation here. So we want to transition from idle into arms forward, and if the condition is grabbing is true, then we want to transition into our arms forward here. And from our arms forward, so let's uncheck our has exit time, and then we can just scrub and have a look at that it works. And well, we can see here down at our preview that something is a little bit weird. The arms are not moving forward. So we need to go into animations and make sure that arms carry and arms forward do not have loop time enabled, because we just want them to do this once and then stay in that position. So let's grab that again, and now we can see that, okay, the arms are moving forward like we expect them to. And then when we want them as well to be able to move back, so with our condition is that we have is grabbing is false. So if we're not grabbing, then we need to move back into idle, and again uncheck has exit time. So and then we have our arms forward, and then it will move back into our idle thing. So that's fine. And then we need to make a transition again to arms carry here, and it uncheck has exit time and check that is carrying is true. And once we are done with carrying, we are going to move back. So is carrying is false. So now we have our animation here, and let's make sure that the weight is set to 1, so it's overriding, and then this whole thing will take over the management of the arms and different body parts. So let's just verify that we have the parameters correct. So transition idle is carrying is set to true, and if we are is carrying, hold on, it shouldn't be is carrying, is grabbing should be true, then we are going into arms forward, and is grabbing is false, then we're going back. Okay, and is carrying true, then we go to carry, and then is carrying false, we go back. So now we have verified that we have the correct parameters and that they are acting correctly. So now we can go back into our scene here, or our character, and we need to implement so that whenever we are pressing the, for instance, G key, that we're going into this grabbing mode. And as our character is physics driven, we need to make sure that we are listening to the animation here. So let's open our prefab, and let's not save this one where we have just enabled our animated night and nothing else. So let's just open our prefab. So here's the original prefab, and then let's go into our night and rig, and then upper arm, and then we have this sync physics object, and then we need to enable sync animation. So, and let's save that. Then we need to adapt our script, but we also want to create a new script which will take care of the grabbing. But now I've enabled a lot of things, so let's just get rid of our shield here. And where is our sword? So let's get rid of that. So on our arms here, we want to create a new script that will take care of our grabbing. Now there are a few options how we can handle grabbing. So one easy solution is to parent whatever we are picking up to our hand slot here, but that creates some sort of problems because it's not physics based. So whatever is happening here it will cause problems with the world, and if we want things to collide properly, and we want to be able to sort of interact with our object that we're carrying, and we want to be able to carry other other characters or drag them, then we need to do something else. So instead we are going to use physics joints for this. So our hand slot here is well, our hand, and instead we are going to create a new object here. So let's do a create child, and let's make it sort of not a parent of our hand slot. Let's bring it so it's on the same as the hand R here, and let's call it Grabb point. And our Grabb point here needs to be it needs to be a physics object, so we need a rigid body, and we can bring it down so it's really light. Otherwise it's going to be affected by the strength of our character, right? So if it's a heavy arm thing here, it's going to affect the whole arm. And then we need some way of detecting whenever our Grabb point here is hitting something. So let's do a sphere collider on it, and make sure that it's slightly bigger than our hand here. Let's move it up. So we already have a collider, right, on our lower arm here. So it's important now that this collider is sticking out, so it can detect things, because we are going to use this as a way of figuring out if something is actually attached to our hand. So it's bigger, and it's going to be sort of hit first before our complete arm is being hit. And then we need to make sure that this rigid body is attached to the rest of our character. So we will need a configurable joint for that. So the configurable joint, lock everything. And connected body is going to be our lower arm here. Upper arm. There we go. And then let's do the same thing, and let's actually figure out why our left arm is not in a T-pose. So no, it's his lower arm that is doing something else. There we go. So now we have our character in our T-pose, and let's copy this one and go into our Grabb arm left, and then just reset the values here, and let's bring it out so it's roughly the same. I mean, let's copy these values, copy and paste. It's a little bit iffy because it's a little bit different, but it doesn't really matter. So now we have our Grabb point there and our Grabb point there, and let's make sure that our connected body upper arm right here is our left instead. So now we have our two Grabb points here, and they are the ones that are going to allow us to attach two different objects, and they will need a script to be able to control these parts. So let's go under scripts, character, let's create new script, hand Grabb handler, and let's open that in our editor. And here's a new thing. I've taken the plunge and I've switched to VS Code instead of using Visual Studio. So it might take a little bit time to get used to, but I really like it so far. So now we have our Grabb handler here, and it will take care of all the grabbing for us. So first of all, let's get rid of our start and update. And then we will need a serialized field, and we need access to our animator, and let's call it animator. And after that we are going to need our fixed joint, so let's add a comment for that. And fixed joint, and let's call it fixed joint. And then we need to access our own rigid body, so let's write a comment and add rigid body 3D. And we also need some references to other things, and we need our network player, so let's call it network player. And we need to get these, so let's do a void awake and then get reference network player is equal to transform root get component network player. And after that, rigid body 3D is equal to get component rigid body. Our script is going to react to whenever we are hitting something, meaning the hands are touching something. So let's add void on collision enter and collision, call it collision. And that's going to be our function for this. And we need, either we can write all our code in here, but let's try to keep it a little nicer. So we'll write just comment attempt to carry the other object, and then add another function try carry object that we need to create, and we feed it with a collision. So this try carry object function, we maybe want to use it later, so we're going to make sure that it returns a value if it's successful or not. So let's make it a return a bool, and then let's have it take a parameter collision and call it collision. And after that we need to check a few things before we even try to carry anything, and that is number one, are we allowed to do it? And so we need to check if we are the state authority or not. So we're checking that by network player dot object has state authority. So if it doesn't, then let's return false. Second case where we're not allowed to carry anything is if we are an active if not an active ragdoll. So if we have been knocked out, we don't want our character to start grabbing things. So let's check that. So we're checking for not being an active ragdoll. And if it isn't, then let's return false. And then we need to check as well, we can only per hand carry one object. That's a limitation that we will have just to make things easier. So we need to check if our fixed joint is already attached to something. So let's check if we have a fixed joint or not. So if fixed joint is not equal to null, then let's return false. Okay, so then we have a few more cases just to keep things from getting weird. And there is one case where we can accidentally grab ourselves. So we don't want to have the character grabbing himself. So let's check that we are not trying to grab ourselves. So we do that by checking our collision transform.root is equal to network player transform. If it is, then we have the same root as our network player, which means we are trying to grab ourselves. In that case, return false. So now we have a bunch of checks, but there is one more remaining check that we need to do, and that is if the object that we're trying to carry has a rigid body or not. So only rigid bodies are allowed to be carried. We can't carry a fixed collider. So we need to check that if there's a rigid body. So let's do a if collision collider try get component and out rigid body, and let's call it other object rigid body. So this function will return true if it manages to do this, otherwise it's going to be return false. And if it returns false, then just our whole function is going to return false. Okay, so that was a lot of just code checks to make sure that we are allowed to proceed with trying to carry an object. So when we are trying to carry an object, we need to use a fixed joint and attached to the other object. Now a fixed joint is a little bit special because it can't be enabled or disabled. So if we look at our code here, we just have a fixed joint, and we have not taken in a reference from some other place. So it's just this value is null at the moment. And what we need to do in that case is we need to create a new fixed joint and attach it to our object here. So let's say that, okay, add our fixed joint. Our fixed joint here is going to be equal to, and then we'll take transform, game object, add object, fixed joint, add component. So we're adding a new component, which is a fixed joint, to our transform here. And after we have done that, we can connect our other rigid body here. So let's do that, connect the joints to the other object. And the fixed joint dot connected body is what is controlling what our fixed joint is connected to. So, and that's going to be equal to other object rigid body. Then we have managed to successfully connect it, but right now the sort of anchors are set to automatic by default. So it means that the connection point exactly where we are connected might not be 100% correct, which will make the character appear like he's not sort of holding on to the object. It's sort of in the air, or well, in the vicinity of the object. So we want to handle that on our own. So let's disable our automatic anchor point here. So we'll take our fixed joint, auto configure connected anchor, set it to false, and if we have done that, then we need to supply our own version of how to handle this. So our transform, we need to change it from world to local space from the collision that we're getting. So the collision, the point that we have gotten in world space. So how do we do that? Well, we do a fixed joint dot connected anchor. So that's our vector 3 here, and it needs to be in local space. So how do we change our collision here, which we can get a point for, from world into local space? Well, we do collision transform inverse transform point, and then we'll feed it in with collision contacts, and we'll just take the first point. The contact is an array of all the contacts that we have received, and we are using it getting in the first point here. And here we see that we have a part where it says you should avoid using this as produces memory garbage. Use get contact or get contacts instead. So that's a fair point, so let's do that. Collisions, get contact, and then 0 and point. So then we have optimized this a little bit further, and then we have inversed it, so we have now the correct connected anchor point here. So the second part is that, or the final part is that we want to start to carry something. So in our case here, we are going to set our animator to be carrying. So animator set bool is carrying, and set it to true. So that's going to change our parameter is carrying in our animator to true. And then we need to return true because we have successfully started to carry something. So that was a bunch of code, and hopefully it makes sense. But we are already going to try this. So already without starting the animator in the sort of our is grabbing mode, we are just going to try this, and hopefully it should just grab anything in the world that we come into contact with which has a rigid body on it. So let's save and go back into Unity. So if you haven't already, make sure that you save your character here, and let's disable our prefab, and then we'll need something that we can carry in the scene because well, nothing has a rigid body on it. So let's go and find a suitable object. Let's go power up block team red. So here's a power up block, so we can use this one. So let's add a rigid body to it, and let's add a box collider, and we need to network enable this. So network rigid body 3D, and make sure that you're adding our network behavior here. So add network object. So now we have a physics enabled and network enabled body here. Now our character is sort of has a mass which is very low and it's not very strong, so we may have to adjust our mass here, but let's just leave it for now, and let's make a prefab out of this. So we have level parts, so let's just grab it in there, and let's make a few of this so we can try different scenarios later on. So here we go. Okay, so now our characters should have sticky fingers or hands, and well, they didn't work. So let's figure out why it didn't work. And network character prefab, and hand grab point. Here's our grab point. Oh yes, we have forgotten to attach our script. So where is our script? Character hand grab handler. So let's make sure that we have a hand grab handler here, and yes, it needed the animation controller as well, so let's make sure that it has the night animated in there, and then let's save if you need to, and if you want autosave, just exit, and then let's try it again. Alright, so here we go, and yes, I think we have a grabbing part here. Whee! And well, it's grabbing for sure, but it is not grabbing as we were hoping, right? There's a almost like the character has the box in a string. So the reason why this is because, well, our sort of iterations or our fixed joint here isn't as fixed as we were hoping, and there are a few easy fixes to it, and one of them is that we can change our physics here and have a look at our solver iterations. So it's on 6 now. Let's add it to, let's crank it up to 255. So let's remember 255. That's maximum. So with 255, it's going to be a lot more fixed. So if we go and get stuck to something now, we can see that, yay, it's actually attached to the character. And let's see if I can get another one. Yes, I could. So great. Now we can pull these boxes around, and they're a bit heavy for my character, but they work. I can't release them though, so we need to figure out how to do that. But now we have cranked up our iterations to the maximum value, and it works for such a little world that we have. It's just a few objects here that needs to be interact with, but it will eventually take a lot of performance. So we need to figure out some better way of doing it. So instead of having default solver iterations to 55, let's leave it at 6. Maybe we can tweak it to 12 or a little bit higher value and see if it works. But another easier way to fix this is by addressing it in our script. So let's open our hand grab handler again. So in our script here, what we can do instead is either we lash on more fixed joints. So for each fixed joint, it's going to be more stable. So we could make an array here of fixed joints and then just add 10 of them. That is actually described in the PhysX manual as a good way of doing it without having to change our solver iterations, and it's probably the most efficient way of doing it. But from programming standpoint, it is a little bit of a task, and I'm not really sure how much this add component dynamically takes from Unity. So yeah, I will do it in an easier fashion. And instead, what we are going to do is we're going to change our solver iteration, but we're only going to change it for our hand instead of every object in the scene. So how do we do that? Well, our rigid body here it has a value to change this. So let's just comment. And ReadyBody.solver iterations is a variable that controls specifically for this ReadyBody how many solver iterations should we do. So we'll do 100, and it is a big change. It's a change from 6 into 100. But if this script, we might be able to use it later on for like climbing and hanging onto ledges and stuff like that. And in that case, I tried a little bit on lower values, but it still flexes a little bit too much in my taste. So for carrying, I think that around 20 would be okay, but for hanging on to things, you'll need more, like 100. So we're gonna go with 100 now. And now it's time to address the sort of sticky hands business, because right now it's only sticking to things that we are sort of walking by, and we want it to work with, let's say that we hit a button instead, and then we're starting to try to grabbing things. So we need to change our code a little bit to accept a new button press. So let's go into our network input data, and here let's add a public network bool is grab pressed. So whenever we are pressing our grab button, this is going to be called. Then let's find our scripts, network and network player, and open that. So let's repeat the process that we have with our other buttons. So bool is grab button pressed, and set it to false. Then let's also add a new state, so we need to check if we are trying to grab something. So let's add that. So bool is grabbing active, and it's false as we start. And our hand grab handler here needs to know if we are have that active or not. So let's make a property for it, public bool is grabbing active, and then just reference is grabbing active. So then we have a public variable that we can access from our hand grab handler. Then let's add our button check here. So let's find our update here, and here we are going to add our check for buttons. So let's check if the key code G is pressed, so get key. And in this case, it's not going to be down, it's going to be repeating. So the user needs to hold down G while it's carrying things, and then when they let go G, they can stop carrying things. So and if it is true, then we'll set is grab button press to true. Then we need to make sure that this works with our network code. So in our get input here, and if we scroll down to object has state authority, so when we are getting our input, then we will be able to know if our grabbing is active or not. So we need to store that. So after our input magnitude here, let's add is grabbing active is equal to, and then we'll do a network input data dot is grab pressed. Then we will know that okay, it was pressed, and then we are setting this to true. And when we have done this now, we can go back into our hand grab handler and add that as a case here. So in our case, we need to make sure that it's in this mode, otherwise we are going to have our sticky hands business. So let's check that after we have checked if we are an active ragdoll or not. So we are checking that we are trying to grab something. If network player is grab active, return false. If it's not, then we're returning false. So as this script is not monitoring our is grabbing active, we need some way of figuring out when we are supposed to start grabbing and when we are supposed to stop grabbing. Because right now, whenever we are hitting something and that the carry is active, it's going to try to pick it up. But we also need to sort of trigger our animation, etc. So let's make a new function for this. So it's just going to be a public void update state. So this is going to update the states of our hand grabber, and our network player is going to call this script. So in our script, the first thing we need to figure out is this animation part. So when are we supposed to raise our hands forward? So we'll check our grabbing state here. So let's do our network player is grabbing active, and if it is, then let's set our animator set bool is grabbing to true. Then it will sort of raise its arms forward as we have set in the animator. And then if it's not, then it means that we are not pressing our grab button, and maybe there's nothing to do in that case, but if we are carrying something, then we need to get rid of that object that we are carrying. So let's check if we are carrying something. And the way we are checking this is the joint is null. And if it's not null, then it means that we are carrying something, then we have something in our hands. And our joint in this case, or our object that we have in our hands, we want to sort of be able to throw it away. If we just let it go, then it's just going to drop to the floor, and it's going to, well, be dropped, but it doesn't look very good. So we're going to be able to give the object a bit of a push. So let's do if the fixed joint has a connected body. In that case, let's add a force amount multiplier that we set to 0.1, so it's very low. And then we need to figure out, okay, what are we carrying, and why are we interested in what we are carrying? Well, if we have let's say a box, then maybe the weight of the box isn't very high, but if it's another sort of player, and especially if they're knocked out, we want to be able to sort of throw them off the map more easily. So let's check if the other party is another player. So how do we do that? Well, if the fixed joint connected body transforms to root, try get component out, and if it is another network player, then this will become true. So if we have managed to get another's network player here, then we can check the status of them. So let's check the status of the other player. If the other player network player is active ragdoll, in that case it means that they are not knocked out. So in that case we still need to have a bit of a force because they are heavier than our boxes. So let's put it to 10 in that case. And if they are not an active ragdoll, then they mean they are knocked out. Then we really want to be able to toss them sort of off the map. So let's do a force multiplier and put it to 15. And then we need to toss this object away. So let's just add some force to it. So fixed joint, connected body, add force, and let's use our just forward for our network player. So the whole network player, whatever direction it is facing, then we are taking that as the direction we are throwing in. And plus, we'll add a little bit of vector up, so it gets off the ground if it's something that is sitting on the ground. And then times 0.25, and that's just a value to sort of decrease the whole thing. And then we'll multiply the whole thing with the force multiplier, and we're going to set it to impulse as well. So the force mode impulse, I'm not sure why it's saying that it doesn't have one, because it should. Let's see if we can save that and get rid of it. Maybe it's visual code that is causing this. Well, I don't know. Let's see. And then when we are done with it, we need to destroy our fixed joint, and then we are done with the destroying part, but we need to fix our animator. So let's change animator state and set it to bool is carrying is false, and is grabbing is also false. Oh yeah, I misspelled it. Impulse. There we go. So yeah, it was the autocorrect was correct. Well, go figure. Okay, so now we've done that, and the other part is that we need to call this somewhere, right? So our network player needs to call this here in our and only if we are the state authority. So let's do we need to loop through all of our Grabb handlers, and so far we haven't gotten them, so we need to make sure that we have them. So how do we do that? Well, we'll do it as we always do with things that we need to get access to. So after timing here, let's add our Grabb handler and call it Grabb handlers. It's going to be an array, and then in our awake we need to get a hold of those. So hand grab handlers is equal to get components in children and hand grab handler. So all of the hand grab handlers that we have we will have access to them. So now that we have done that, we can go down into our network code here, and here we are. So after we are in the fun fixed update network. So in this case that we are going to do a for each loop here. So and let's add that. So for each hand grab handler, and call it hand grab handler in hand grab handlers, and hand grab handler update state, and then close it. So there is one tiny more thing that we need to do, and that is when we are getting reset, and for some reason like falling off the world, we need to make sure that we are resetting our state here as well. So make active ragdoll, I think we can just do it in here, and if we are making ourselves an active ragdoll, so in that case is grabbing active is equal to false. And as well on make ragdoll, so let's make sure that grabbing is not active. And one tiny thing that we forgot, but important, network input data get network input needs to have our button check here. So if is grab button pressed, then set network input data to is grab pressed to true. And as we have a continuous key press, we don't need to reset it, so that should be fine. So now we can save it and try it. So let's start our game. And then our character has spawned, and yes, so we can grab things, but we have an error saying is grabbing does not exist. So let's have a look at our network parameter, and okay, so I had a different spelling. Is grabbing with 2 B's or 1 B. So once again, let's try it. Alright, so now I press the G button and he's raised his arm in a forward direction. And yeah, now he pulled up his other arm, and the state doesn't detect when I'm releasing things. So yeah, there is some work to do with our code, I think. So my release code is not working, and let's see if I revive myself. Yes, then he let go of the box, I think. No, he didn't. So we need to check why our release code is not working. Perfect. So let's stop our game from running. So I have a suspicion that our code for our key presses is not correct. So let's open our network player and just have a quick look. and whenever we are collecting input, so where's our update? So here's our update, and so we're saying, okay, input key G, the continuous test is gather, and we are never setting this to false. So yes, and we can do it this way instead. So is grab button press is going to be whatever we are getting from our get key press here. So, or get p key, period. So nothing else. That should make sure that this is flipping correctly, dependent on if we have the key G pressed or not. Okay, so let's save and try it in Unity. Okay, and before we try it, let's reduce our mass on this object to 0.5, so they are less heavier, and let's make another one, and let's make it in twice as big and a little bit heavier. So twice as big, twice as heavy. So we can try some cases with some different mass, and we can see how our character reacts to those. Okay, so let's try it again. Okay, so G, yes, I can grab and I can stop grabbing, so that's good. And now I have two objects and I could let them go, and the thing is, yes, I can throw them, and well, hold on. But the heavier one is a bit too heavy, and our animation here, the grabbing, and it should raise this box above the ground, right? So if we pause and have a look at our animator for our network object here, let's go into our animated. We can see that he has arms carrying. He is executing this animation, but our character is a weakling, so he doesn't have enough strength in his arms to carry the whole box. So we need to fix that, and we need to strengthen his strength in his arms. So let's open our character prefab here and increase his arm strength. So if we look at our upper arm here, we and both of them, we actually have different position spring strengths, which is not great. So one of them is 5 and the other one is 7. Both are quite low in that case. So let's add 5 and let's position dampening 2, so we'll get less jittering when we're trying to carry things. And let's check our legs while we're at it. So legs 10, yes, those are okay. And let's check our spine, position spring 100. We are going to carry some heavy boxes, right? So we need to increase our spring here and dampener on that one as well. And let's check our root. So our root has 100, and we can damper a little bit here, so we get less jitter. So now we can save it. Before we start again, another thing we can try is, let's move this to the side a little bit. So let's duplicate it and let's see how well we can hang on to things and with our character. So using the grabbing feature. So let's just bring it up a bit and put it to is kinematic. So that should allow the character to sort of hold on to it. So let's try it out, and I've compiled a client, so let's take a first spin with that client. Alright, so let's try it now and see if our character is a bit stronger. So yes, now he is able to lift it off the ground, well, at least with 2 hands, I think. Yeah, sort of. Yes. So now he's strong enough to lift up a small box. He can pull, I hope, a big box. Yes. And, well, alright. I fell down. And let's see, well, Let's check the grabbing. So grab, still a little bit flexible. It's not my day today. Let's see if the grabbing is a little bit better. Yeah, it's still a little bit flexible, and it depends on when you grab onto this. So let's just compare it and crank it up to the highest value. So let's take our grab value here and let's crank it up to 255 and try that. Alright, so now we have the highest value, and yes, it's really sticking in onto that block now. So if you need climbing, bring a higher value, and that's the highest value, 255, and it also makes grabbing these blocks a little bit better. And so let's try it with a client as well and see how that works. So let's wait for our client to connect. Oh, there it is. And let's grab him and throw him off the map. Yay. Let's see if we can knock him out. Oh, I have him and the box. Great. Oh, well, I knocked him and myself out. Let's try to just bring him. Jump and kick. Yes, it works. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. Thanks for watching, and don't forget to like and subscribe. I'll see you in the next video.